Last video, we spoke about some basic classes. We spoke about a class and we spoke how each one has an init function, which is what it starts off with, and we use self to reference the different attributes inside it, and we can even build in functions to our classes that allow us to manipulate those particular classes. And the way we access the attributes is the way we access anything inside a class is we'll create a specific instance because we don't work on the general one, work on a specific one, and we say hey equals car and then the name and the whatever attributes we fill in. So that's when we create the car, and later we can access stuff by saying name dot and then the thing we want to access. Now we're going to talk about something a little bit more specific. We're going to talk about, or a little bit more specific and useful, we're going to talk about how to override some of the default things in classes. So we have, for example, when I print Jack, I print out the string car.car object. Why is that what prints out? Because that's the default definition for any object that's going to print out the type at that thing, right? So if I use the type function, right, which is a built-in function for Python, and tells me the type of anything, and I run this, it says type is a class of car.car. Now I can, for example, just run the same thing on the number 85, and it says type is class int, right? And I can do this with whatever I want. In this case, we don't want to actually determine the type. We don't want to know the type and where it's stored. We want some useful information. For example, we want to know that it's, the make, model, and the current mileage. So what we're going to do is we're going to override the default function. What's happening when we print? Print says, hey, convert this to a string and then and then print out that string. So it takes a number, it converts it to a string, and then it prints out that number. Or it takes a list, it converts it to a string, and it prints out that list. Every single class in Python that is there by default has a built-in string, like toString method, which converts whatever it is to a string, and Python decides what goes in that string. We have something specific that we want in our string, and so what we're going to do is we're going to define what goes in our string. So the __str method is the method that converts it to a string, and it's just going to return, where all that this method does is it takes in self and it's going to return it's expected to return a string. So we're going to define that string as an f string, and it's going to have this is a, right, we're going to say this is a, and then it's going to be self dot make space self dot model made in, and then we're going to have the year, and the year is going to be self dot year with, and then we're just going to do self dot mileage miles on it. All right, so this is a f string, and I don't know if we've spoken about those before, but we will speak about them soon if we have not. And all that this does is it allows us to reference variables and write code inside the squiggly brackets, and it converts that to strings and gets the data we want. So this is actually writing code inside a string to make our lives easier and make it really easy to read this line. What are the actual implications of doing this? If we go back over here and we see how I'm printing out Jack, and I run my function, I run my thing again, now it says this is a Honda Civic made in 2022 with 82 miles on it. So now instead of just giving me, hey, this is an object, it actually gives me some meaningful information about the car. And we can do the same thing with Lucy, right? Because they're both instances of the class, when I change the class, I change both of them, right? This is a Ford Mustang made in 1967 with 57,133 miles on it. So that is how we override a class, or that is how we override the specifics of a class. Now, there are a bunch of other things that we can override. We can basically override everything. For example, if we want a way of comparing two cars, we want to have a definition for if a car is greater than another car. We'll call it greater if it is, the greater car will be the older car, which means it'll be the one that has that the year is older. So we'll define, because right now if I compare two cars, I don't really get anything, right? I say, let's just let's just print the result of Jack is greater than Lucy, right? Oops. Jack is greater than Lucy, and we run this, and we get an error because it's not supported. The greater than comparator is not supported between instances of car and car. Basically, there's no way to no one defined, hey, how do you compare two cars? We have to go and define it as part of creating our function. So I'm going to say define. So I'm going to define my function def gt, right? Gt is greater than. And we're going to take in self, and we take in other, right? So it's the self and the other, which are going to be two cars, and we're going to compare them. How do we compare them? We say return, and we're just going to write one logical comparison here. So return other, so self dot year is greater than other dot year. So whoever's year is greater is going to be the newer one. So run, and now I don't get an error anymore. I actually get back a true. Why? Because Jack is 2022 and Lucy is 1967. Just like that, we've defined what this operation does, like how we compare those two things, and now it works. But if I try, instead of doing greater than, less than, if I try doing a plus, what happens? I get an error. What about if I do a less than, right? We know that a greater than works because I defined greater than, but what about less than? What happens if I run that? It still works. Why? Because Python is really, really smart. It knows that greater than is the less than and greater than are opposites. So if greater than is true and greater than has a definition, then I just check greater than and I do a less than. And Python, being really clever, makes our lives a lot easier. But what about less than or equals to? What happens if we run that? Nope, that's not supported. Why? Because greater than and less than versus greater than, and if you do or don't have the equal to, that actually matters, right? Because the equals can change it to be something different. So we have to define an equals to if we want to get this error out of our way. So we would say greater than equals, right? That should be it. Sorry, GE, greater equals. And then we just do self, whoops, already did that, and we do other. And what's happening here? I want you to recognize that this is, like I said, these are functions, right? This less than and equals to is actually a function. What does it take? It takes in the thing on the left as first part of the function, and then the second thing on the left as the other, and then it just runs a compare, and then it does whatever our comparison rule is. And we're going to say self.year is greater than or equal to other.year. So now I save that, I run my function again, and bang, we've got that. Now, what about a plus, right? Let's what about if we add two cards together? So that's a little bit weird. But I think we're gonna just make up some random thing just to demonstrate how we can do a plus. So we're gonna do add, right? When we add two things together, that's the default is add, self and other, and we're going to return a car, and the car is going to have the following values. It's going to have self.make, other.model, and it's going to have the year is going to be, it's going to be self.year, and then mileage is going to be 0. Now we can write a more elaborate definition if we want to, but we'll just say that we take the make and year from me, and we take the model from the other car, right? Because we can always just combine the two together if we want to be ridiculous, right? We can say and other dot make, and then we do other dot model plus self dot model And this is going to make it just a little bit ridiculous, but it will work. So we're going to run this, and so far nothing happens, right? But now we're going to print out Jack plus Lucy. And now we run this, and this is a Honda Ford Mustang Civic made in 2022 with 0 miles on it. A little bit ridiculous, right? But it's a definition that we decided. And we can decide anything, right? We can decide that every time anyone tries to add two things together, as long as it returns the right type, right? These expect a Boolean to come back from comparisons, right? We expect a comparison to compress into a Boolean, and we expect an add to return the same data type that it started off with. Usually. It doesn't have to necessarily, right? We can just say add is going to equal self.year plus other dot. Or actually we can do, let's do self.mileage plus other dot mileage. Right? And now if we run this, we have a new definition for what happens, and we get back a different result, right? We get back the combination of those two numbers together. We can say that that's how we compare stuff. We can also say the same for equals, right? So greater than and less than we have a definition for, and we have to, let's do a definition for equals. And let's just say that they're going to be equals, and a logical thing to say would be they're equals if it's the same make, model, and year. Return self.make is other dot make, and self.model is other dot model, and self.year is other dot year. Right? That's how we're going to compare the two, and we run this, and nothing happened, but Jack is Lucy, and we run that, and we get back a false. Why? Because they're not actually the same thing. But if we changed it, so if we created Lucy 2, right? Lucy 2, and we say Lucy 2 is Lucy, and we run this, that is going to be, why is that false? I am not sure. Other.make and oh, this is one of those annoying things where if I use is versus equals versus something else, Python can be very funny with how it decides certain things. But if we run this, still printing out false. It's because we should do that. Now if I run that, it's gonna that was a mistake. We can undo all of these and save, and that should still be true. Yep. It's the equals over here that because we only overrode the definition of equals, we didn't overwrite the definition of is. And is and equals are technically two different things, right? Define is. And we don't have a definition yet. We don't have an override function yet. That's not really important. What's important though is we have a way of defining how we want to compare our two cars. So in this class, I realize it was a lot. In this video, it's kind of a bit, but all it does is it's just showing you a bunch of examples of taking classes and overriding the default methods so that we can use our built-in stuff that we're used to in Python in meaningful ways. Like we can just print out information about the car instead of this like meaningless string that it's a this or particular thing, or we can add cars together, compare cars, or comparing cars to see if they're greater than, less than, or equals, or things like that. And that is something which is highly valuable big picture once we start creating our own objects and making them useful. Right? That is all we got to cover in terms of built-in functions. If you have any questions, please let me know.